Hey everyone, welcome back with Mrs. Struble. Today we're going to be learning about the product of powers property. So in this video we're going to simplify expressions involving product of powers, power of powers, and the powers of products. Now lots of P words going on here, so I'm going to break it down a little easier for you, don't worry. We're also going to practice writing equivalent expressions that involve those products of powers. So let's go ahead and get started. Here's some algebra notes here. This is just the basics of what is really going down. Okay? So we've got three different properties all involving products and powers. Okay? So the first one is what we call the product of powers property. And that's our basic one that says, hey, if you have two values with the same base, and they're to a power, then just add those powers. Okay? So the algebra rule here is a to the m power. No matter what a is, no matter what m is, if I'm going to multiply it by another a, so the same base, with a different power, just add those powers. Okay? Then we have what's called the power of a power rule. And that's where we have a value taken to a power, but taken to a power again. Okay? So it looks in the format of a to the m to the nth power. Okay? Just as you see here, a to the m to the nth power. Now when we do that, trick of the trade, the rule is just multiply those two exponents. And once again, we're going to cover the reasoning why, okay, in our examples. So bear with me. The power of a product property says if I have two values being multiplied together and I'm taking the entire product to a power, then what I could do is I could break it up and I could send that power to each factor inside. So the m would go to the a and to the b, both individually, okay? All right, let's dive into actual examples. It'll make more sense that way. Here we have a couple of examples. They're going to cover that first property, the product of a power, okay? So we have 2 to the 4th power, just going right straight through the examples, times 2 to the 5th power. Let's break this down into what it actually means. In order to break it down, let's use expanded form. 2 to the 4th power is 4 2's all being multiplied together. Okay. 2 to the 5th power, well, the exponent tells us how many factors of 2 there are. So there are 5 2's, again, all being multiplied together. What's happening here is we're multiplying two terms that have the same base with a different exponent. So, well, we're still all multiplying. All there is multiplication in this problem. And that's why we have exponents, is to make something as elongated as this a little more simplified. Okay? That's repeated multiplication of the same value over and over. So how many 2's do we have in total that we're all multiplying by? And 2 to the 4th, 2 to the 5th, well, there's a total of 9 2's all being multiplied together. Let's just write it in exponential form instead of expanded. And so we have 2 to the 9th. Okay? That is why this rule of adding those exponents works. Because all we're doing is multiplying the same thing by itself over and over and over. Okay? All right, let's take a look at B. All right? We have -5 times 6 -5's. This does not have an exponent, but it's understood that there's still one. It's still 1 -5 right there. And all we're doing is multiplying in this problem, so we can essentially say that, hey, this is -5 to the 1st power, 1 plus 6. And yes, you have to have those parentheses because the negative is included. Okay? The negative is with each and every single one of these 5's. So let's include it in that exponential form, negative 5 to the 7th power. Final example here in the basic ones. We got x to the 3rd times x to the 7th. Well, easy peasy. Now that we understand the rule, x3 plus 7, x to the 10th. Okay. All right, let's talk about the power of the power. Okay, this is that rule where we are supposed to multiply the exponents. But why? Exponents talk to the characters, or essentially are talking to or referring to the character immediately in front of them. Okay, so this 4 is talking to the 3. This means there are 4 3's inside these parentheses. 1, 2, 3, 4. They're all being multiplied together. However, these 3's are being taken to the 3rd power, okay? So now we take a look at that exponent of 3. This 3 is talking to the parentheses. That means that there are 3 sets of these parentheses. These 3's are happening 3 different times, okay? So 1, 2, and 3. Expanding it all out, okay? So we got 3 groups of parentheses. In each set of parentheses are 4 3's. We're still only multiplying. When I have a parentheses right next to each other, it's still multiplication, okay? So we still only have multiplication, and we have the same factor repeated over and over and over and over. Let's count up all the 3's and put it in exponential form to make it easier. 4, 8, there's 12 3's. Turns out this works all the time. If you have a power of a power, 4, or you're just multiplying those powers. So 4 times 3, 12. Okay, let's do the next one. We've got w to the 5th power, all to the 4th power. Okay, so w to the 5th to the 4th. Well, as we just learned in the one above, that's just 5 times 4. So we got w to the 20th power. We do not need the parentheses because w is just one value that's unknown. If I told you that w was a negative number though, okay, you have to remember that the 20 goes with w. It doesn't matter if it's a negative. So if I tell you evaluate it if w is equal to negative 1. Question is, does the negative go with the 1 or not? Well, if w equals negative 1, then anywhere you see a w is going to be negative 1. So I like to have you guys practice using those parentheses when you're substituting in like this, okay? Because the w is what the 20 or the exponent is referring to. So yes, that negative goes with it. The negative goes with that negative, the exponent here, because it's part of w. All right, kind of jumping the gun there. Let's talk about that last power rule that we're learning here. Okay? Power of a product. So now we have a product inside. So we're multiplying something inside, and we're taking that to an exponential rate. Okay. That's called a product. What this rule states is, for example, if I have something I can simplify out a little more, that's where I'd want to use this rule. Okay? So I have 2x all to the 3rd power. So the product of 2x to the 3rd. Okay? Well, I don't know what x is, so I'm kind of stuck unless I know this rule. And what this rule says is, hey, there are 3 2x's. Okay? So there's 3 of each, 3 of these parentheses. So the 3 goes with the parentheses. There's 3 sets of parentheses. In each set of parentheses is a 2x. 1, 2, 3. Okay? If we remember our basic rules of multiplication, and remember that's all we're doing here, there's no addition, subtraction, or division, we're still just multiplying. If we remember our basic rules, we can remember the commutative property that says I can rearrange this problem, because 5 times 3 is the same thing as 3 times 5. So rearranging all of these little factors here, I can put the 2's together because all we're doing is multiplying. I can move them around and say, hey, this is the same thing as 2 times 2 times 2 because there's 1, 2, 3 2's. And then times x times x times x. Okay? I'm grouping those similar factors together. Now what do I have? Well, I have 3 2's all being multiplied together. So I could say 2 to the third power. Ooh, that's not a 2. I could say 2 to the third power. But the whole point behind this property is to simplify the parts of this product that we can. So we know what 2 to the third power is. Well, 2 times 2 is 4, times 2 is 8. So we're going to put 8. Okay, that's the whole reasoning we have this property here. Okay, so we're going to pull that out. We're going to say, hey, you know what, let's just say 8. We know this one. And then we have the x's, and then there are 3 x's. So that is x to the third. And lo and behold, there's no more parentheses. It's a little bit easier for us to comprehend. It's 8x to the third. So what does this rule say? This rule says, hey, if you have a product, that exponent goes with all factors inside. Let's practice. Okay. In B. Now this time we're not going to expand it out. We're going to use the rule. Okay. The 2 is going with the parentheses. That means everything inside the parentheses gets the 2, gets the squared. Okay? So that means we have 3 squared, we have x squared, and we have y squared. We have everything squared. It goes with each of the factors or each of the guys inside here individually. Okay? Now we can simplify it even further because we know what 3 squared is. We know 3 squared is 9. So we're going to say that's just 9x squared y squared. And voila. Okay? How does this apply in the real world situation? Well, here's an example. Okay? If I have a gigabyte of computer storage, if I know that 1 gigabyte of computer storage space is 2 to the 30th power of bytes. The storage details of a computer, as shown here, this is just some random computer information, okay? The question is, how many bytes of total storage space does this computer have? How many bytes, not gigabytes, okay? So I know 1 gigabyte is equal to 2 to the 30th bytes. Okay? Well, let's take a look. How many bytes of total storage space? Total storage space. So I've got 64 gigabytes of total storage space. How many bytes? What am I going to have to do? Well, if 1 gigabyte is 2 to the 30th, I want to know what 64 gigabytes is worth. I'm going to multiply. Okay? I'm going to multiply 64 times 2 to the 30th. Okay? So I'm going to scroll down here just a tad bit so we can do that multiplication. All right? So we have 2 to the 30th times 64. Now I'm going to show you a little shortcut trick, okay? We know something about 64 if we're really good at our multiplication. Okay? If we're really good at our multiplication, we know that 64 is the same thing as 8 times 8. And we also know that 8 is the same thing as 2 to the 3rd power. So what we're really looking at here is 2 to the 30th, ready, times 2 8s. And each 8 is 2 to the 3rd. I just did a little product of power trickery, making those bases all the same. Okay? When you get really, really good, you can realize that 64 is just 2 to the 6th power. Okay? What's the rule when we're multiplying bases with different exponents? That was that basic one. They have the same base, different exponents. What do we do when we're multiplying them? We just add those exponents. Okay, so 30 plus 3 plus 3. Hey, we have 2 to the 36th. Yay! And now I don't need to worry about how big this number is going to be. It's just 2 to the 36th bytes. Okay? In other words, hey, dude, this is a big number. Okay? All right. Let's go ahead and have you give it a shot. So here are 9 practice problems. Go ahead and pause the video, give them a try, and we'll discuss them in a little bit. All right, now that you've given it a shot, here are your answers. Okay. One thing that I do notice trips people up is the directions, oddly enough. Okay. So simplify. What does simplifying really mean? Simplifying does not mean to solve necessarily. Okay. Simplifying the expression in this case, when we're dealing with these types of problems, what they're generally referring to is rewriting the expression in exponential form. Okay? If we can combine anything, we're combining. We're not actually solving these unless they ask us to evaluate or solve the expression. Okay? There's little bit of difference here in the wording. Now, when you get to problems such as 7, 8, and 9, however, these ones, when you're simplifying, you can simplify those coefficients. So the 5 and the 5/10, those can be actually evaluated out because we have variables involved, and it is more simplified to evaluate those coefficients part and then simplify the variable part. Okay? Hope that kind of makes sense. All right. Now, thank you for joining me in this video where we discussed the product of powers property and how to simplify and rewrite expressions involving not only product of powers, but powers of powers and also powers of products. And now I hope you know the difference between those. Okay? Thanks for joining me. This is Mrs. Struble with Struble Math. Have a good day.